Okay, so last week we talked about inverse matrix a little bit. Let's review. So if a matrix has an inverse matrix, okay, if a matrix does have an inverse, do we call that singular or not singular? Not singular. Okay, so make sure you review vocab, not singular. So if it does not have an inverse, we call that singular. Now, if you have a matrix and you have another matrix, you want to see that whether they are inverse of each other, so you multiply them together. If you multiply them together and they are inverse of each other, what should the resulting matrix look like? Yes, identity matrix. Okay, so make sure you keep all that in mind and review them often as you go. So if a matrix times another matrix and they are inverse of each other, you should get an identity matrix. Now, the way we did it last week was not the fastest way to find an inverse matrix. The fastest way to find an inverse 2x2 matrix is this way. So let's say you have A, B, C, D. This is the matrix. And you want to find the inverse matrix. Inverse matrix, you have a -1 on the top. That tells you inverse. Okay, so that -1 means inverse, not reciprocal. Okay, so then what you need to do first is find the determinant. I write DET, but it's determinant. Okay, determinant. Okay, the determinant is going to be this one. We called it the reverse breast cancer awareness sign. So you start from A, go down to D, wrap around C, and then go back to B. Okay. So what you're going to do is you start from A, and then you multiply A and D together. That's why they're linked. So A times D. When you go back to the left, that's a minus. And then C and B are linked together, so C times B. That's the determinant. We're going to use the determinant to help us find the inverse matrix. So the inverse matrix is going to be 1 over the determinant, usually we write DET, and then times the matrix. Now the matrix is also going to change according to this reverse breast cancer awareness sign. So you see how I linked A and D together? So we're going to switch them. So A and D switches, so it's DA like that. B and C are linked, and what you're going to do is make both of them negative. So I'm going through this quite fast because you learned it last year. So if you still need a refresher, go back to last year's notes. I don't remember what chapter. I think it was chapter 12. I think. It's been a few years. So yeah, just go back and review that. Okay. Determinant of a 3x3. All right, 3x3 matrix. Let me just show you by actually doing it. Okay, so let's go ahead and try this one. Determine whether the matrix has an inverse. Now, how do you know whether a matrix has an inverse or not? The fastest way is to check the determinant. If the determinant is 0, it means the matrix has no inverse. Okay, so let's try A. Matrix A is 3, 1, 4, 2. So we want to first check the determinant. Okay, so that's going to be A times D minus C times B. So 3 times 2 minus 4 times 1. So what is that? 2. So is there an inverse? Yes. As long as that number is not 0, there is an inverse. Okay, now that we know there is an inverse, how do we find an inverse? 1 over 2. Okay, now what do we switch? A and D, so 2 and 3, and then what? Make the other parts negative. Very good. All right, so we have 1/2 times this matrix. 1/2 is what we call a scalar because it's just a number. We don't leave it there. We do want to multiply it in. So that means basically multiply everything by 1/2. So this is 1, -1/2, -2, 3/2. Good? Kind of? All right, now let's do B. So we haven't done this yet. B, again, if you want to check to see if something has an inverse, you want to check the determinant. This is a 3 by 3 though. All right, so hopefully once I tell you, you will be like, oh, I think I remember this stuff from last year. What you do is you take the first 2 rows and then you copy it to the right. 1, 2, 2, -1, -1, 0. Yeah, then you find the diagonal. So first take the first 2 columns, copy it over to the right. Then what you're going to do is you're going to draw diagonal lines starting from the left. You can only find determinants for square matrices for this reason. It just makes no sense. You can't find determinants for rectangular matrices. All right, what you're going to do is you're going to multiply down the diagonal. So 1 times -1 times 1 is what? -1. All right, I know the numbers are easy, but it would be nice if you guys can tell me the answer. All right, okay, so second one, 2 times 3 times -1. -1 times 2 times 0. Okay, 0. So we know it's 0, but a lot of times I see this on tests. People put something like 2 or -1 or 1, something like that. Just be careful, you're multiplying by 0. A lot of people just add it in their head, so it's wrong. So please be careful. All right, we're going to add these numbers together. So we get -7. Next, we're going to find the other 3 diagonals from bottom left to upper right. And we're going to do the same thing. We're going to multiply them. -1, -1, -1. -1. 0, 3, 1. 0. And then 1, 2, 2. Good. All right, we're going to add them together. 3. And then what we're going to do is the bottom number minus the top number. Okay, so the determinant is -10. So is there an inverse? Yes. As long as the number is not 0, there is an inverse. Next, I am going to show you how to do it on your calculator. So you must have a calculator today. All right, so take out your calculator. So there is a matrix, like the whole matrix is kind of stuck in this button. So you're going to go to second. Okay, x to the -1. On top of that, it says matrix. Okay, so go to that. And then you're going to see 3 columns. Names, math, and then edit. So what you're going to do first, since you don't have any matrices in there right now, you're going to go to edit so you can create a matrix. So you're going to scroll over to the right, and then you have options. Do you want to create matrix A, B, C, or whatever you want? Let's just do A. So you're going to enter, and then you're going to be in matrix A. All right, we are trying to ask the calculator to find the determinant for us. So we need to put in matrix B. Now, you got to tell the calculator what size matrix B is. What is the size of matrix B on your notes? 3 by 3. So you're going to put 3 by 3. And you don't have to scroll to the right. Just press enter. It will automatically go to the next thing. Okay, now you're going to see 9 zeros where you're going to put in your matrix. So you're going to put all your matrix elements in there. Just remember that if you want to put a negative sign, you got to use negative, not a minus sign, or else your calculator is going to have error. Okay? So put in all those 9 numbers, and I'll tell you what to do next. Okay, once you finish editing, what you're going to do is you're now going to perform some operations on your matrix, which requires that you go back to the main screen. So to go back to the main screen, if you have not done that usually, is you go second and then mode, because on top of mode, it says quit. Quit means quit whatever thing you are on at that time, and then go back to the main screen, the calculation screen. All right, now that you're in the main screen, everyone's in the main screen, right? You're not in the matrix. Okay, if you're in the matrix, that's the wrong place to be. Okay, now, now what you're gonna do is you're gonna go back to matrix and then go to math. Okay, now when you go to math, you can see all these things that you can do to a matrix. The first one, I believe, is DET, right? That means determinant. So click enter. Like that. Go to the math section. Okay, now you need to tell the calculator, find the determinant of matrix A. So you need to select matrix A, and to do that, you go to second matrix again, but this time you want to stay in the names part, because now you need to choose. You're not going to go to edit because you're not editing your matrix. You are going to choose matrix A. So names, and then you're going to just press enter, and then it will automatically pick A. And then press enter. That should give you -10. Good? Okay, so since I am not going to make you do a inverse 3x3 by hand, you're going to use the calculator to also find the inverse matrix. This is very easy. So you still want to be on the calculation screen. So what you're going to do is click choose matrix A. Again, choose matrix A means second matrix, and then choose that one. Okay, choose matrix A. And then what you're going to do is put the -1 button, the inverse button. The inverse button is that button that you chose matrix from, x to the -1, that will automatically add an inverse. And then press enter. It's an ugly matrix, but that's the inverse matrix. Are you guys with me? No? Yeah, now we need to go into the more advanced mode. All right, so we're going to learn how to transpose matrix. To transpose matrix, it means we are going to switch the rows and the column for ease of calculation. Transpose matrix is just going to be a mirror image of the matrix. So very easy. So what happens is sometimes you have the rows going this way, the columns going this way, and they represent different categories. And sometimes you don't want them to look like that. You want to switch them. So then the rows become the columns, and the columns become the rows. And that's it. It's just a way of reordering your data. And the way we write it, so let's say B matrix looks like this. And if you have this T on the top, that means we're going to transpose it. So what you're going to do is think of this diagonal as if it's a mirror, and you're going to take the numbers and then flip it across the mirror. Okay, so the mirror does not change. So 1, -1, 1. And then the two sides of the mirror changes, they swap. So 2 and 5 are opposite of the mirrors, so they swap. And then 5 comes here, and then 2 goes up there. So it's a way of switching all your rows into columns. It's just a way of reordering our data. Okay, next. Across from the mirror, or the diagonal, you have 4 and -1. So 4 and -1 are going to swap. Okay? And then the last two numbers, 0 and 3, they're also going to swap. So this is the transpose matrix. Okay, the whole idea is to switch the rows and the columns. Can you guys see that? The 1, 2, 4 became 1, 2, 4 here. And then the 1, 5, -1 become 1, 5, -1 there. So we swap the rows and columns. Okay, and we can just use the calculator to do that for us, which is what we're going to do next. So let's look at this problem that actually requires transpose matrix. A florist makes 3 different cut flower arrangements for Mother's Day, 1, 2, and 3. That means the different arrangements, each involving roses, carnations, and lilies. Matrix A shows the number of each type of flower used in each arrangement. All right, let's look at this. What does 1, 2, 3 mean? Hmm? Yeah, they're the columns, but what does 1, 2, 3 mean? Huh? The days? No.
Wait, arrangement for
the different arrangements, correct. Now, what does this 5 mean then?
Wait, 5? Oh, it's like how many numbers of roses?
Uh-huh. How many numbers of roses?
Flowers for that day. For
Day.
that arrangement.
For that arrangement.
Yes.
Okay, so this is a word problem which requires that you really, really understand what this matrix means. 5 means there are 5 roses in arrangement 1. Okay, so then what does this 7 mean then?
7 carnations in arrangement 3.
Correct. 7 carnations in arrangement 3. All right, so now the next part. The florist can buy his flowers from 2 different wholesalers, W1 and W2, but wants to give all his business to one or the other. The cost of the 3 flower types from the 2 wholesalers is shown in matrix B. Okay, so W1, W2 means wholesaler. So then what does this mean? What's that? 95 cents. Carnations? From wholesaler 1. Yes, wholesaler 1 sells each carnation for 95 cents. Okay, so that's what it means. All right, so here is what you need to do. Construct a matrix showing the cost of making each of the 3 flower arrangements from flowers supplied by the 2 different wholesalers. Okay, so we need to figure out how much it's going to cost from each wholesaler to make the 3 arrangements. Okay, so, all right, so we need the cost of making each arrangement from 2 different wholesalers. So this is kind of crazy what we need to do here. So let's kind of analyze it a little bit. What is the size of matrix A? 3 by 3. The first 3 means rows, right? Row by column. What does rows represent? The flowers. Remember, rows go horizontal, so that means the flowers. What does the column mean? Arrangement. Let's just call it type. Arrangement's too long to write. Okay, so columns are the types of arrangement. Okay, let's look at second matrix. What's the size? 3 by 2. What does rows mean? Flower. What does column mean? Sorry. Wholesaler. Okay, so we're trying to figure out how much it's going to cost to make a arrangement from each wholesaler. Let's say that we multiply these together, and they name them A and B. Okay, so let's multiply them together. Let's first check. Can we multiply them together by their size? Like, does the size allow us to multiply them together?
Yes.
The size? A times B? Okay, all right. What's the size of A? 3 by 3. What's the size of B? 3 by 2. So can we multiply them? Yes. Remember, as long as the 2 numbers in the middle are the same, we can multiply. Yes? Okay, now let's look at the other. Not everything that size, where the size matches can be multiplied. Let's look at the actual category. For matrix A, what are the categories? What by what? Flowers by type. What about matrix B? Flowers by wholesaler. So can we multiply them together?
No.
No. They're not the same. Yes, they're not the same category. So even though the sizes tell us we can multiply them, the actual categories does not allow us. If you force to multiply them, sure, of course, calculations, you're gonna get some numbers, but the numbers make no sense because you're mixing up all your categories. So you cannot do that. How do I multiply them so that the categories in the middle are the same? Transpose. I need to transpose which one? The first one, A. So I need to switch columns and rows, right? That's why we transpose. If we switch columns and rows, it's going to become type times flower. Now the two in the middle are the same. We can multiply. Are you guys with me? Okay, so if I change it to A transpose B, then I'm going to get type times flower, and then flower by wholesale. Let's make a prediction. What is the size of my final matrix going to be? 3 by 2. 3 by 2. What's the category of the 3 rows? So when you multiply them together, first you check, are the two in the middle the same? Yes. Then the final one, if you recall, is going to be the last two. Okay, so we're going to get a 3 by 2 matrix that is type by wholesale. So the type of the arrangement by each wholesaler. Okay, so this is where you take out your calculator scale. You're going to put in both matrices, A and B. I don't know how to erase the matrix, so you're just going to try to override it by just typing over it. So you're going to go back to edit, and you're going to put in 3 by 3 for A, 3 by 2 for B, put in all your numbers, and then when you go back to the calculation screen, you're going to do A transpose. So transpose is found in the math button. So if you go to the math button, there is a function for T, means transpose. A transpose B, that should give you the actual number. All right, so try it with your partner. If both of you are stuck, let me know. I will help you. All right, so now this is my final matrix. Remember, the rows mean type, the columns mean wholesaler. So this is type 1, type 2, type 3. This is wholesaler 1, wholesaler 2. So then let me ask you, what does this number mean? 21.6. The cost of arrangement 2 from wholesaler 1. Okay, so who do you think the guy is going to go to for his Mother's Day arrangement? Maybe wholesaler 2, because in general he is much cheaper. Yeah, so this is how you look at all your data. So make sure your column and rows are correct in category, so then you don't multiply something and then realize, oh, it doesn't make any sense.